Hey guys, welcome to this video where we're going to go through Tic-Tac-Toe. Now I want to say that I thought I had recorded this a long time ago, but I had somebody ask in a comment on a different video, where's the Tic-Tac-Toe video? And I thought, well, I'll just go find it for him and get him a link, and I didn't see it. So, it might be out there. Uh, Maybe like when I first started doing these videos, I like grouped a bunch of them together and like they were just like session number 3 or whatever it was. So it might be under one of those, and I just don't know where to look for it. But I also don't think it hurts to just do it again. So along those lines, if you can find that other video, which you might be able to, or if you look at my solution online, these are not necessarily going to be the same thing. That's like if you can find that, it might be interesting to see how I do different, approach the problem a different way at a different point in time. It's not to say one is better than the other. It just speaks to the fact that a lot of times these decisions, like there isn't necessarily a right answer. It's a set of trade-offs, and depending on what's going on in my brain at the time or the context or just a bunch of things, like there's lots of good choices, and which one of the good choices to pick is not necessarily always obvious or consistent even. So anyway, we'll go from there. We're just making tic-tac-toe here. And we'll just start working through these more or less in the order that the bullet points list this. So 2 human players take turns entering their choice using the same keyboard. The player designates which square they want to play in. The game should prevent players from choosing squares already occupied. So we'll get to all of these. I think the place that I feel like I want to start, and we could do CRC cards, but I'm gonna. There are CRC cards on the website for Tic-Tac-Toe. I'm gonna not worry too much about that, and I'm just gonna start by kind of fleshing out in code. That's actually like honestly, I like CRC cards. I think they're a nice simple tool, but I tend to think in code better than I think in cards anyway. So unless the problem isn't well suited to cards, or sorry, well suited to code, that's what I'll usually do. So the first thing that comes to my mind is I feel like what we need is a data structure to represent the board. And so, board, and we'll make a private placeholder private. So we'll make this field will be to store the whether it's an X or an O or empty, which we need some way to represent that. We could use ints, we could use characters. Like I literally see a lot of people who will do something like a 2-dimensional array of characters, and then this will like literally be, X or O or space. Like I see a lot of people do that. I don't love that myself, just because it leaves open there's just more risk inadvertently having somebody throw in something like that, which is a different character, or that, which is also a different character. It looks similar, and it may be subtle. It may be hard to recognize. So I will almost always make an enumeration for these types of things. So I'm going to make a public enumeration cell type and just do XO empty. Having said that, remember the default value for an enumeration is the first value in it, and I think empty is the better default, so I'm going to move that one to first. So empty X and O. And now we'll just make this cell type. And then we can just say equals new cell type 3 by 3. I also see plenty of people who will prefer, a 2-dimensional array. It's going to require a little more work than that, but strictly speaking, that is, it's slightly more performant. This type of thing is ever so slightly faster. However, for me, it makes it less readable, and I would almost always prefer code that's readable to code that runs ever so slightly faster. It's a super rare thing where the performance matters enough for you to like sacrifice readability and understandability of the code. So for me, this is the easiest to understand. It's my preference here, so I'm going to do it that way. And so in theory, and we could initialize this in a constructor. I don't I think this initializer for the field itself is good enough. And notably, since our default value down here is empty, I don't have to do anything fancy to like initialize this to cell type empty. I need more curly braces here if I want to do that. We don't need to do any of this stuff. That'll be the default value, and I think that works pretty well. I don't even need this constructor. All right, so this will, if I come up here to my main method and just say board new board, poof, now I have a new board and it's empty. This is exactly what we want to start the thing. I can also make this read-only. So let's go ahead and do that right now. I always prefer read-only if I can do it, especially if the thing I won't necessarily make something read-only if it's read-only by coincidence. If I just haven't gotten around to making a change to it. In this case, though, given that the contents of the array is changeable, it's mutable. I could come in here and change the individual values within cells. This read-only, and I will want to do that. But in this case, making the field read-only means that I won't be able to replace the whole thing. I won't be able to update this memory location where cells is. So in this case, it's a natural fit for it to be read-only. So I'm going to make it read-only. And now, so kind of marching forward here, the next kind of thing that I think we'd want to do is be able to change spots on the board. And it's at this point that a lot of times people want to, or either change spots on the board or view what's on the board. So at this point, a lot of people will say, okay, well, what I really want to do is console.write line board dot set. I want to access that 0, 0. Let's just display this. But because this is private, I can't do that. So some people say, okay, well, then I'm going to make this public. It compiles at that point. Although if you do that, then you want to change the capitalization here because private fields are usually underscore lowercase. Public ones are usually capitalized with no underscore. The catch though is this is data, it's private for a reason. Objects should be good stewards of their own data. If there's any sort of rules to enforce, any sort of limitations or restrictions, things that must always be true, the object that owns that data should have the capability to enforce that. And if, just as an example, let's remove the read-only for a second here, and if I make this public, now we run the risk of somebody doing something like this. Cells equals new cell 200, sorry, cell type. So now all of a sudden, this board it's 200 by 200 instead of 3 by 3, which is going to be problematic. We're going to write code that's going to expect this to be 3 by 3. So, obviously making this read-only would prevent us from doing that total replacement here. But if there's any sort of rules that we want to enforce, the challenge asks, that we don't want to change, if something is already X or an O, you shouldn't be able to play there. Then making this public the object can no longer enforce that, which is not great. The object should be able to protect its own data from outsiders meddling with it. And the main reason for that is that it makes it easier to understand the code. You can think about each individual object and or class, since all objects of the same class are going to look and work the same way. But so it ensures that like any sort of like enforcement of these rules happens inside of the board class. But obviously that we depending on what it is, we may still want the outside world to be able to see what's in that cell or ask for it to change. If we make this private, then at the beginning we lose our ability to do that. Like we right the second we no longer have the ability to like say, hey board, like what's in here? Is this an X? Is this no? Like what are we looking at? So we need to add methods or properties or some mechanism to allow us to give data, these operations that the outside world does want to be able to see. We need to provide those. I will say that there is a thing called an indexer that we'll talk about in part 3. We're not ready for that today, but we'll get to it. It is that, like, if I had a full set of tools, I'd probably use an indexer here. We don't have that, so I'm just going to use methods for what I'm doing here. It won't make sense to use a property for what I'm doing here because I need a parameter. But anyway, so what I'm going to do is make a public cell type get cell at int row int column. And then, hey, look, the autocomplete already suggests exactly what I want. So now up here, I actually have the ability to say board.get cell at 2, 2. So that's the bottom right corner. Well, I guess it depends on how we define this. That's always a good thing to do, is define our coordinate system. I'm going to say for this program, the first thing is row, the second thing is column, and rows start at the top and go down. So 0, 1, 2, and then 0, 1, 2 going from left to right. That's what that little 3x3 grid means. So this would be the bottom right. So at this point now I should be able to run this. We'll see what it displays. This is a very normal thing to do where, like, I don't have the whole program, but let's see where we're at. Let's run it and see. So this is empty, which is exactly what we'd expect. And if we added in a few more of these, we'd be able to start seeing what the board looks like. For example, just pick a few locations here. So the top left, the middle, and then the bottom right. Empty, empty, empty. All right, we're making progress here. Like, obviously, that's not how we want the board to appear. We don't want it to say empty. We want it to just look empty. We'll get to drawing the board more in a minute. I am, however, going to turn this into an expression body. I prefer those. Not everybody does. To me, it's less code, and it's easy. It's both less and, for me, easier to understand, at least once you get used to the syntax of this little, expression body, the fat arrow operator. Now the next thing we'll do is what we want is maybe the ability to, for instance, come up here and say board.set cell at, pick a location, 0, 0, cell type dot x. So if we want to be able to set a thing, sorry, there should be a void method. And once again, expression body, I think, should work here. Yeah. In this case, we're going to get to it in a minute. We're going to add more logic here. But now at this point, let's see. What did I say? I said 0, 0. So let's display 0, 0 again. So it should start empty and then turn into X. So that's exactly what we want. And now we have these methods that allow us to modify what's going on here. We are going to want this board to enforce a rule, and that is that if I've already changed a cell to be, an X, then it should fail. So I guess let's put this back to being a block body and say if cells at row and column is not cell type dot empty, return. So that if it's already full, it's got an X or no, then we return. I do wonder though if we might want to know that it failed. And so one thing we could do is return false. It was not successful, and down here we return true. And now we'd know whether it failed or not. So at this point, if we came down here and set it to O, then what we'll see here is this should start empty, get turned to X, and then when we attempt to turn to O, it shouldn't actually change it. So if everything is done right, that's what we'll see. So we set it to X, which it changed to, and then we tried to set it to O, and it did not change. So now we have code that enforces that, like, once it's been set to something that's not empty, it stays that way. So at this point now, it actually is there's a pretty clear and obvious case, I think, for having, making this private and having these methods to kind of provide that data or like allow us to set the data, because there's a rule to enforce. Let's suppose there were no rules to enforce. Do we still need all this, or could we just make that public? This cells, could we just make this public and just, if there's no rules to enforce, how much does it matter? If there's no rules to enforce, there starts to be a more compelling argument for just make it public, just make a public field. However, my take is that yes, you could make it public, but barring some, I don't know, like a public field is ever so slightly faster than like these method calls. Unless there's some deep, abiding, like performance issue that you gotta deal with, I would say just go ahead and make the methods. And the reason why is because invariably there's going to end up being some sort of constraint on a bunch of this stuff. If you just make the thing private and then just define the methods that you need, then when those things crop up, when you do realize, oh, there actually is a rule I got to enforce for this bit of data, when that happens, then it is available. Like, you don't have to change anything. Like if we had just made this a public cell type, 2D array, and then we decided, oh, actually we do want to enforce this, we don't want anybody doing stuff, then the code I would have had here before would just be board.cells 0, 0 equals cell type dot O, right? Okay, that's what it would have looked like, and now the whole API, the way that you interact with the object changes, and so you must change a whole bunch of code in order to make that change. Now, obviously, sometimes there's going to be changes to like that the public outer shell, that boundary, that the API. of what the object, like how you interact with the object. Obviously, that's going to happen sometimes. You're going to have that a little bit wrong, and you're going to have to make some changes. But the less often you can do that, the better off your code will be. The more easy it'll be to maintain it and grow the code over time. So unless there's some truly compelling reason, I would say even if your your methods don't do a whole lot, prefer making them to just having public fields, just because it does give you the room to maneuver in case you need to maneuver. And like I said, an indexer would actually allow us to get syntax kind of simple. Like that's one of the things is that like this board.setCellat is a bit uglier than board.cells00 equals cell type.o, right? Like this is, I think, a little simpler, cleaner code. With indexers, you can actually achieve something more or less like this too. So we haven't talked about indexers yet, so we'll save that for now. But when you get to it, you could come back and revisit this code and make some changes to it. So with that said, we've actually checked off a handful of these. We haven't done anything with the player, nor have we done anything with like displaying the board. We haven't done anything with like a game, like running a game. And I think maybe that's the next step, is dealing with either players or maybe displaying the board. So maybe I like to, if I don't have a compelling reason to do otherwise, sometimes it's nice to just keep taking as small steps as possible. So which of those two seems easiest? Well, you might say one thing or another. Right this second, I'm feeling more in the mood for the rendering. I feel like that's a little easier. So we obviously need some code to draw the board. And I think like it's pretty natural for people to say, well, let's just put in like a public void draw method here, right? Like we just throw in here some code to draw the board. I'm gonna like, let's run with that for a minute, but then we'll talk about the design of like, is this really where we want it? But for the moment, let's just, well, I say that, but now I'm thinking of it like the example in the book actually has it is X's turn. What square do you want to, and shows the board. What square do you want to play in? That's actually more like focused on the game, isn't it? Like that's not just about, like that's not just drawing a board, that's drawing the state of the game. So maybe we're not ready for drawing yet. All right, everything I just said we'll come back to. Like I said, I'm yeah. All right, so the next thing I think that we maybe want then, given that a little bit of insight, I think it might be easier then to focus on player input. And so what we need is for people to be able to pick a location. And I think there's a hint in here. You might consider using the number pad as a guide. It's like you look at the number pad on a keyboard. 7 is the top left, 9 is top right, 1 is bottom left, 3 is bottom right. So one thing we could do here is we can make a player class. And we could do something like this. So we could say public placeholder for a second. Pick location. And maybe we give it the whole board, right? So what we'll do, and I often think of it this way, like when I'm first kind of fleshing out a class, I think like, how am I going to want to interact with this? Well, it'd be nice to do something like player 1 equals new player p1 dot pick location, and give it the board, right? Something like that. So So I like to think before we get into the actual logic, I like to think about like, well, how do I like what should again that public outer boundary? What should that look like? It's that the public part is a lot more important to get right than anything on the inside. Because if we change our mind about how we want some little detail on the inside to work, it's trivial to just change it. It won't affect anybody because it's all on the inside of this. Like the only thing that it could possibly affect is this, like from these lines of code, because it's just the implementation details. It's the inner workings of the object. But the outer shell could have an impact across the whole program. So we're talking about the possibility of change over 6 lines, 7 lines versus 33 lines, and that's only going to get bigger as we add more code in. So getting the public API, the outer shell of how exactly do I interact with this right, getting that part right, is more important than the details on the inside, because we can change those more easily. So what should this look like? Well, we do need to, like in this case, we're hoping to return something. And like we could return a number 1 through 9. Like we could just say public int and just return a location, right? And that would just be, 1 is row 2, column 0. 2 is row 2, column 1. 3 is row 2, column 2, or whatever it is. Like we could do that. Or we could say we're going to do rows and columns. We could make a tuple here. I actually don't dislike that. I think that's a pretty reasonable solution. I tend, like for me, and maybe it's partly because tuples didn't exist when I started programming in C#. But I think it's more than that. I think tuples are great for small ephemeral things. And the second I'm returning it, I'm expecting something else, the game itself, to like do something with this. I don't like. I like having a concrete name first. Like I like having a name rather than just a tuple. These are just the names, especially with tuples, are just so fuzzy. So what I actually am going to do is come down here and make a public class location. I'll do public int row, public int column, and public location int row, int column. There. So now I have a location class. I do want to mention that when you get a little bit later in the book, there's this concept called a record. This, to me, screams record. I think this would be a really good place for a record, which you could basically define exactly the same thing in a single line. We don't have that tool yet, so I'm going to write out the full class. But now I can come up here and I can say, give me a location. I do want to say, though, that like another thing I see a lot of people do here is just have the player like play into the board. So rather than return anything, we just make this void and we just do board dot set, set cell at, and just pick the thing and just change it. I think that could be a reasonable solution. The reason I hesitate to do it that way really comes down to how do I want to distribute the responsibilities across these classes? And in particular, so like I said, if you've chosen to do it that way, do it that way. It's going to be just fine. But the reason that I have chosen to do it this way is I actually want there's one bit of trickiness with player input is I want to like if they well, let me put it this way. Like I'm kind of thinking ahead here that there could be more than one kind of player. We don't need more than one kind of player here. We need one. It's just ask the human to pick a location, and then we pick it, and then that's it. Um, Strictly speaking, if we just expect the player to like play on the board, like there's one bit of trickiness, and that is if they pick a location that's already been chosen, I want to do it again. I want to try again, right? However, I don't necessarily want every like if I have a different kind of player, like an AI that like analyzes the board and picks a location, I don't want to have to like duplicate that logic of if the chosen location is already occupied, try again. I don't really want um, players to have to do that, and it also runs a little bit of a risk of a bug or possibly something malicious just filling up the whole board with stuff. I think returning the location conveys better. You're just supposed to tell me something. I guess in this case, it doesn't prevent somebody from writing a version of this player that just says, "Oh, board, no board dot set cell at 0, 0 to my thing and set 1, 1 and 2, 2 and 0, 1, 0, 2 1, 0, like all just fill the whole board with X's. Like as a strictly speaking, this doesn't prevent that because the board class is not enforcing turns, and maybe it should, but it isn't today. So there is, but I do think that saying players should return a location puts me in the right mindset that my intent is just to pick a location and that is it. So that's all we're going to do here. We'll just do console.writeLine. What square do you want to play in? And then we'll say int.parse or convert.to int32 int.parse console.readLine. This is giving me a warning about null. I could check for null. It's not going to be null, but convert.to int32 handles null just fine. So maybe that's the better one for right here. And then, so we have this int and we need to turn that into a location with a row and a column. So what I'm going to do is return, well, let's do it this way. Location. I'm going to call this location number, and then location equals location number switch. I love switches. I think they're fantastic. I like switch expressions way better than like switch statements. Anytime I can use a switch expression over a switch statement, I will. And so in this case, all I need to do is, if it's 1, then we're going to return a new location at row 2, column 0, right? And then 2, new location, row 2, column 1. All right, and then we can just say return location. Except I think I'm going to just skip all that and just say return that. So depending on what they pick, we'll do this. Now, there's multiple, we're not handling all the bad inputs here. If they type in a number like 77, this is going to blow up. If they type in garbage, like if we can't do this convert.to in 32, it's going to blow up. We don't have all the tools to do like perfect, super robust error, user input handling. We will learn more tools in the future. I'm going to not worry about it too much right now. This is a low stakes game. Like, we're worst case scenario blows up, we got to rerun the program. So I'm not going to worry too much about the bad input handling here. If the stakes were higher, because like I said, these just doing this random little challenge here, the stakes are super low. But if crashing meant losing, paying customers data, if it meant, launching the world's nukes or whatever it is, like obviously those are much, much higher stakes. You would need to handle the input way better than this. But this is like, stakes are low here. So let's not worry too much about that and just trust ourselves. We're pretty much going to be the only user of this. Trust ourselves to get it right. All right. Let's see, a couple other things that I'm thinking of here. Like, this is saying this is never even used. I like, all right, boom, it's gone. I mentally just added that in. Like, my brain is thinking ahead already of like, we could, like, this could be an AI player. Like there could be an alternate version of this that's like a second type of player that player would need to be able to inspect the board. And strictly speaking, maybe we should do that here. Maybe we should down here say, like, for example, we could make a method here that's public bool is occupied. Right? Like, if we come down here and make this method is occupied, and we could come up here and say, while I actually think I want this to be just a while loop, and I'm going to do while true, which obviously normally I don't want to loop forever like this, but so while true. So now what I'll do here is I'll just say, I'll come back to this location, get my location, and then if board dot is occupied, so if it's not occupied, return location. So if we found a good one, we just return. Otherwise, we're going to come down here and say console.writeLine. That spot is already taken. Try again. And then it'll just loop around. So like the loop itself doesn't naturally have an end, but at some point we're going to hit this right here and leave the not just the loop, but the entire method, right? So we like all of that extra stuff. I don't know that we need to do that here. Like, it's reasonable, but I think we could check that elsewhere. So now we have player. So now, but at least at this point, now this player, this version of player, actually uses this board, which I mean, it's usually at about this point in learning object-oriented programming, especially if you haven't done much with it in the past, that people start to say, how exactly do I get objects to like work together? Because people often end up like just making a bunch of like static things, so they can just access the other stuff. Um, and I know I've talked about this in a bunch of other videos, but like this right here is a way to do it. You pass like it. This, at least in the context of this method, this player knows about the board that it's supposed to be picking a move for. Because it's like a reference to that other object is passed in here. So within this method, we have it. If, on the other hand, we need the we need it for like the like lots of methods, and we don't want to just keep passing it in over and over again. Well, we could come in here and say public player. So this is the constructor for the player class. We could get the reference here and then save it off. So we could do and now the player knows about the board forever, and it can use it forever. And so like now in here, we would not need to pass this in. We would just use the field instead of the method parameter. This is like the most common way for one object to like know about another, especially if it's like this long-lived thing, is that it's just given it in the constructor and that's it. It just hangs on to the reference forever. But if it's something that's more transient, then the constructor thing won't work, which I guess I should mention since we're on it. That's one of those things a lot of people miss. There's a section in the book in level 23 called How to Collaborate. It's the last section in that chapter. And it talks about how to get objects to like know about each other, which a lot of people either like. I feel like I've done like enough people have had issues with this that I have messed up. So if you're in that boat, welcome to the club. But that like walks through like if you have these objects, they need to know about each other. How do you do that? That section walks through how to do it. And like the two most common ways are this constructor, a constructor dependency. If player depends on a board, like this is like the most common way to do it. The what we had a moment ago, which is what I'm actually going to go back to. Passing it in via method parameter is also very common. Of course, the other option, which won't work here, but if we we could just say, we could just make a new one. Poof, we're done. Like, we've got it. The catch in this case is I'm actually going to have multiple players, and they all need to know about the board. So they can't each make their own board, or they'd be playing separate games. So that's another common way to do it. Obviously, at some level, something's always going to have to call new whatever. Like, someone has to make the object in the first place. But anyway. All right, so we have a player class that's pretty close to working. And we could actually have like almost a working game here. All we have to do really at this point is we make a player, and then we pick a location, and then we say board dot set cell at location dot row, location dot column, and then cell type dot, let's just do X for now. And the other thing I'm going to do here is I'm going to add another line here so I can put a breakpoint so we can inspect some stuff. So I'm going to run this and, okay, what square do you want to play in? Well, let's play right in the middle. 5. Enter. And so now we come in here and inspect this board. We can expand this, and it looks like 1, 1 is now set to X. The user can't see this. Like, we're in debug mode. We're inspecting the memory of our program, but it did look like it did it. So In fact, at this point, well, we actually have almost a working game. One thing that I want to do is the player, like I kind of want the player to know what it is. So if I just come in here and I say public cell type, I'm going to add in a property for that, and then I'll do that, and then that. Now the player itself has this data, and we'll set it to whatever the player is. So now if we run this again, I pick a location 5. Oops, I want my breakpoint in there. Let's try that again. 5. So now my board is X. But if we say, well, this player is actually O. No, let's pick a different square this time. Now 1, 0. So, so it is working correctly. We just, like, we almost have a full game. We just need two players. And then I'm taking some shortcuts here, which, by the way, this is like pretty normal. Like I and most people will do this kind of stuff all the time. Like we're obviously in the middle of building this. We build it and like test some stuff out and see how things are going, even though the thing isn't completely done. All right, so the current player, and then so we will say we'll get the we'll get the location, and then set it, and then current equals current. This is going to read a little weird, but if the current player is player 1, then we'll switch to player 2. Otherwise, it must have been player 2, and we switch to player 1. So this will alternate between the two players. And now we actually have most of the logic for a working game here. Like nothing's going to like end the game. So we're eventually going to run into some trouble, but like 5, let's see. I'm going to put my breakpoint back in here. So we play right in the middle. Enter. The board has an X there. And continue. And now we should be player 2. So let's do the top left 7. Enter. And now the board is 7. Oh, yep. So we are making progress here. We actually, and this would keep going forever, but eventually we'd run out of places to play in, and this check we would eventually have a full board, and we would never leave this loop. And no one would nothing would recognize that as a win. All right, the next thing that I think makes sense here. Well, okay. I think the next thing to do here is we are starting to get a bunch of logic in here for a game. And the main method often has a bunch of logic. I tend to prefer having the main method essentially do nothing except create the objects necessary to run the program and get them launched, like get them in motion. Which means, like, if you look at this, like this stuff actually is doing that. But like this while loop is not that. Like this is other logic. And if the program is small enough, I'm not going to worry too much about it. However, it seems like we're now at a point where having a game object makes sense. So if we do public class game, this is going to like public void run. Like this goes in here. And maybe this goes in here. And then like, I mean, does all of this just go in here? Maybe. And then up here we can just say game equals new game. Actually, while we're at it, let's rename that to Tic-Tac-Toe game. And then call game.run. So now we have this method, this object that has the mechanics in it to run a game. Having said that, this gets back to what we were talking about how does one object find out about others? Well, it has multiple options. Like one of them here is that it just creates new whatever. We see 3 examples of that right here. There is a certain advantage to not having this guy just create all this stuff. And the reason why is, again, imagine this hypothetical scenario where we have 2 variations of players. One of them that's exactly what we have here. It just asks the human to enter a number, basically 1 through 9, and then it just picks a location. But we could also have like a second type of player that is an AI player. And we could actually start, like, to keep things simple, that could just pick a random location. It doesn't even have to be very smart. If we are doing this new player, then we're committed to using exactly this specific type of player. If, however, we pass this in, so if we do Tic-Tac-Toe game, player P1, player P2, and maybe we do the same thing with the board. Like if we're given these things instead of just create them ourselves, then it gives us some extra flexibility. Which is actually probably a good thing. Now, I don't think we want any of these changing on us as we play the game, so we'll make them all read-only. But now at this point, I'm going to actually move this stuff back up to here. And pass it all in. Now, like I said, we don't have the tools yet to make these different like types of players that like are easy to swap. But in theory now, like the tic-tac-toe game isn't really committed to a specific type of player. And this will just give us some flexibility that depending on configuration or game mode or whatever it is, we'll create a different type of player. And then hand that off to the game itself. So the game doesn't care where these things are coming from. I can make a second game that uses totally different players. Or for example, I could make you know, 4 players, and then have so this gives us this extra flexibility that this thing isn't committed to like specifics. That's all a lot of like software design stuff. This book, like what we're doing right now, isn't super focused on software design. That is a very important like thing to learn and be good at. But like I said, there's your version of this, especially if you haven't done a lot of object-oriented programming, is going to look different. take the parts of this that are useful, ignore the parts that aren't. Everything's going to be fine. Looks like I got some cleanup to do down here, though. Okay, there we go. So now, like I said, this is more along the lines of what I typically strive for with my main method is I create the objects needed to run the game, run the program. In this case, it is a game. And then just set it to go. And that's all it does. And everything else lives elsewhere. Yeah. So the next thing is, I think, the rendering. And I started going down this path. Like we could do something like this: public void draw, and have this guy just like draw the board. And so I'm going to just kind of go ahead with it like this. And then we'll talk about a little more about software design here in a moment. But let's see. So what I'm going to do is just kind of throw this together here really quick. So that is close, but not good enough. But what I will do is show you this. Let's see. Not there, right here. So after we set it, we will say board.draw. Tell the board to draw itself. And this is what you get. Empty, 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 X, empty, empty. Like this doesn't like look good, right? Because all these empties and X's and stuff. Well, and first of all, I did miss something important here. These horizontal lines. All right. Yeah, so I did the problem is that this is like when I just write cells 0, 0, it's just taking the default representation of a cell type, one of these, and just using it. And that default representation is just however this thing appears in text. Now, actually, for this X and O, that's actually pretty good. For empty, not so much. And so a lot of times people will say, well, okay, how do I get this to, like, what I want this to be is, I don't know, like a space. Well, I can't very well like name an enumeration value space. Like it doesn't like it doesn't compile. And so it's like, well, what else could I use? Well, maybe I could use an underscore, and now I have underscore X and 0. I'd have to change this to underscore and underscore, and now I actually get something that kind of vaguely looks kind of right. That's not, in terms of display, that's not terrible, right? But people naturally start to say, like, how am I supposed to do this kind of thing? Well, I would say name your enumeration values, what makes sense to understand quickly in the code, and then write some code to convert. And you may have to write code to convert each way. In this case, I think what we can do is we can just come down here and have a little private method, private character to so we just make a method that'll just convert a cell type to a character. And then, okay, that's this suggested just directly cast it. We definitely don't want that. What I'm going to do though is I'm going to use the expression body, and I'm just going to do cell type switch, and just use the switch here. So if it's cell type dot empty, then we'll just do a space. And if it's cell type dot x, we'll use an x. If it's cell type dot o, we'll do o, right? No big deal. I maybe makes sense to like, what if it's something else? There shouldn't be anything else, but maybe we can do like a question mark or something, and then we're covering all of our bases here. So I think that's a reasonable thing. Let's do that. I of course now have to call this method, and I'm gonna unfortunately have to like do that here and everywhere. Like I'm gonna have to do that a bunch of times. Let's see if I can remember the keyboard shortcut for this. Yes, I'm holding down Control Alt and then clicking, and you can see maybe that I now have multiple cursors, all these different places. So now I can type to character. Poof. All right, there. Multiple edits all at once, and now I'm calling like whatever this is. We just figure out what character should be and just use it. And now our drawing should look pretty good. There it is. So now it's O's turn, so now I pick another one. So this looks like we are in pretty good shape here. However, okay, so now it's time to talk about like, where should this stuff live? Or at least how do I decide where this should go? Like, we just slapped this in here into board, which isn't a totally unreasonable place to stick it. If there's one thing that you learn about object-oriented design, it's this next thing. And this is something that is really easy to misunderstand or get wrong. There is a principle that I feel like is one of the most important but most misunderstood principles in software design, especially when it comes to object-oriented design. There's this principle called the single responsibility principle that says that every object should have a single responsibility. Pretty straightforward, right? The catch here is that it can be very hard to like pinpoint, what do we mean by single responsibility? When I see a class like board, I think, oh, well, its responsibility is the board. Representing the board, if I need to ask questions about the board. And for example, like all this stuff here definitely fits the bill for that, right? Like get cell at, set cell at, like it's got the actual data for the contents of the board. This is occupied. Like all of that makes sense. And when you think about that, like that we're drawing the board, like it makes sense for us to stick this on here. The problem is that I don't like just the basic definition of that doesn't really like it isn't nuanced enough. It's easy to accidentally misunderstand and to think, oh, this is great. This is perfect design. There's nothing wrong here. The problem though is that, like I said, it just doesn't give the right nuance to it. And so the single responsibility principle, it's not like it's brand new. It comes up there's a book called Agile Patterns, Principles, and Practices by Uncle Bob, Robert Martin. And he describes a single responsibility principle. And then in another book that he wrote, he said, look, this is a widely misunderstood principle. And he tries to like define it a little better. And I think it is better, but my take on it was I still didn't quite get it. Like it still didn't like snap into place. But this principle also, I think, is the same principle as this idea of organize your code based on areas of volatility, which also I don't think is very just intuitive. So here's my thing about it. What you should do when deciding whether something should be a class or not, and there are other things, but this is a very important tool to go into your toolbox, is if stop and think, like, is there multiple ways to do this? And two, if there are, do I actually plan on leveraging them? Like, am I going to need that? And the reason why is that given, like, we don't have a full set of tools yet, but once we learn about inheritance and interfaces and polymorphism in the coming chapters, like that's immediately after we get done with tic-tac-toe, you'll see that it can be very easy to create objects that are very different from each other, but that all look the same and are swappable for each other. So things like the player thing that we were talking about earlier, things like maybe this drawing stuff, given these other tools, like it becomes easy to make things swappable, which is a key part of making software that's actually changeable, software that's actually soft enough that we can bend it and twist it and turn it into what we need it to be. And that, I think, is like the heart of object-oriented programming, really, is build software that can be changed easily. And that with the right set of tools and the right like mental models, it can be easy to do that. So we slapped this drawing code directly on the board class. However, let's ask those questions. Is this something that makes sense, that there's different competing strategies for drawing the board? I think the answer to that is very clearly yes. Like, yes, we're just, like, you can see how this works right now. It's just this. I could imagine maybe wanting to substitute this out for something else. I mean, for example, maybe in a desktop app model, like a WPF thing or a MAUI program, we could do it that way. Alternatively, we could run this in a web browser. Like, we could like use Blazor, or we could use JavaScript, and we could like take this stuff and show it in a web page. We could stick it in Unity or Monogame or something like that. Like, we could stick it in a game engine. There's so many things, other ways that we could do this. Similarly, we might make a board, a tic-tac-toe board, that's used just for like building like an AI that like learns from itself, in which case it doesn't need the baggage of this like drawing code. So in a sense, like having it here is actually like in the way of some of this other stuff. And so ultimately, the answer to the first question is yes, there's a lot of ways we could do it. Even if we just stuck to the console, there's a lot of different ways we could represent this. Like we could not just have this little grid and these, X's and O's. We could have some color. We could do, like, there's a lot of things we could do. And just having this ability to swap one thing for another, swapping one renderer for another, basically makes it a whole lot easier to make changes over time, and to use these pieces individually. And I think that in my opinion, is really what the single responsibility principle is getting at, is things should have one reason to change, and everything related to that change lives together. And so in this case, where we say, well, is there multiple ways to render the board? Yes. Well, okay, then any code related to board rendering should get pulled together into one object, and in a different object than the code that's unrelated to that decision. It's just just the name. If you just hear the name, single responsibility principle, objects should have one reason to change. It doesn't necessarily scream the thing I was saying a moment ago. Because you look at this and say, oh, well, why shouldn't draw, beyond the board? It's part of the board. So, of course, the next question is, are we ever going to take advantage of that? Are we ever going to make a different renderer? Which is the second of my two criteria. The first is, can you easily imagine competing strategies for it? And two, are you ever going to use them? And I'd also say that if you're not sure, err on the side of it's probably given enough time, you're going to want to change it. If you're sure that you're not, then maybe don't worry about it. So like in this case, I am 100% sure that we will not leverage the ability to swap out one renderer for another. Why? Because in 15 minutes time, we're going to be done with this challenge and probably never come back to it. Like we're going to be on to the next thing. So we won't make that change here. So leaving this in here with his draw is going to do no harm. Like no practical harm is done by just doing this. However, if this were something that were longer lived, I would be itching to separate this into another class, to follow that single responsibility principle. And so I'm going to just go ahead and do it. So is this strictly necessary? No, it's not. But I think it's good design. Let's go back to our little Control-Alt-click here and edit in multiple places because we're going to have to make a change here. Oh, man. Oh, good. All right. There we go. So now we have a renderer that has a you can call draw on it, and you give it whatever the board has. You can draw any board. We could more strongly associate the renderer with a specific board by having a constructor, passing the board into the constructor as a parameter, and then saving that off to a field. We could do that, but I don't need to do that here, so I'm not going to. And now I'll come up here and I will say make a new renderer, pass the renderer in here. There. So now we've made another object. And like I said, now it's a lot easier if we do end up having a different type of renderer. We can do it here. So everything is looking the same. Like everything's looking like it should. And now our rendering code is pretty flexible. Like we can swap that out if we get to a point where we need it. Now, there's one last piece of information, and that is we do need to be able to tell when the game ends. This is some of the so there's a design question here, and that is where does this go? Does it go in the tic-tac-toe game? Does it go in the board? I don't think it makes sense for it to go in the player or the renderer. Oh, actually, before we move on to that, I just remembered. The renderer, actually, I don't want to draw a board, I want to draw a game. Then we'll pass in this context, like where this is the game, so we pass in ourselves, the whole game, draw. It looks like if I want to do that, I'm going to have to make a property here, public. You know what? I'm just going to replace this field. Public, board. But I'm going to make it get only, so nobody can set it. There. Because I want the renderer Well, what I want is to be able to do this first line. Console dot, right. It is game dot current player This is one of those things about if you can get this design right in the first place, it gets a whole lot easier. So I'm going to upgrade this current player here. Rather than just having a local variable in here, I'm going to make it well, I'm going to make it a property. This should be a player though. We're almost done. We really are. All we have to do is handle the win checking. But now, current player dot cell type. Now, in theory, we might want to use logic similar to where's our renderer? Like we might want to turn, like this is also going to just do, yeah, I mean, let's just throw that in there too. Character. Like in theory, like given that the current player will always be X or O, in theory, like we shouldn't need that. Like the string representation, like this natural representation of this will be exactly this, and same here. But if we ever decide that we want this to be, like if we ever decide to change X to player 1 and O to player 2 or something, well, now this will still work. All right. It is X's turn. It is O's turn. That's backwards, isn't it? It is, and it comes down to the order that we're doing this stuff in. We have them pick a location. The current player picks a location. We update the board, and then we draw the board, and then we do that. So what I'm going to do, and this is going to fix another issue too, I'm going to have the drawing happen first. The other issue that we had is at the very beginning, you didn't even see the board, and now we have it. Okay, there we go. All right, so the last piece that we need here is win checking. So again, there's this question of like, which object does that go in? Does it go in the board, the player, the renderer, the game? Does it go? Do we make a new object? I don't think it makes any sense for the renderer to do the win checking. Given how we've defined player, I don't think it makes sense for player to do the win checking either. The board has the information it needs to make a determination. It seems like it might be more of a game-related thing than a board-related thing, though. And maybe there's an argument for another object. And we talk about kind of that single responsibility principle. Is there multiple ways you could do this, and are you ever going to leverage them? And if so, you probably want to separate that in another class. Is that true here? Tic-Tac-Toe is such a simple game. It's hard to imagine alternate like win conditions, so different strategies for deciding a winner. Having said that, I'm sure Google would find lots and lots and lots of variations on Tic-Tac-Toe. For example, a version where if you can get 3 in a row, you must get 3 in a row. But the purpose is to be to not be the one who has to get 3 in a row. Totally different win conditions. If we want to support that kind of thing, where we can swap out how to decide a winner, it makes the most sense to put that in another object, because then it's easy to swap the thing that's deciding winning versus losing from the rest of the game mechanics. So this like alternating turns back and forth kind of stuff, or whatever it is. And so I think they're anyway. But again, that question: are we ever going to do that? Well, obviously, once again, just like the rendering, there is zero chance that we are going to actually make that, like actually apply a different strategy. Because in a few minutes here, we're going to be done with this challenge and walk away from it probably forever. So does it actually make sense to, jump through the hoops, go through the trouble of making a separate class, or do we just stick it in maybe the tic-tac-toe game? I think that's the right question to be asking. And again, this is the thing about software design. Somebody, like two reasonable, level-headed software engineers, could come to different conclusions on that. And that's what makes software design tricky. So maybe it's just because I've already been working on this for an hour and a half. Maybe it's because I really don't think we need different, like the probability of a different renderer in my mind is a lot higher than the probability of a different like win conditions. Or maybe it's just to be different than the last time. I don't know. But I'm going to add the win conditions to the tic-tac-toe game. Having said that, I am going to see if I can like keep it in separate methods and stuff so that if I do need to separate it down the line, I have that option. So what I'll do is this. So this is going to be the thing that tells me if I win, lose, or draw. So what I'll do, I actually think so. There's a lot. So at this point, the design parts are over, and what we have left is like algorithms. How do I know whether I have a win or a loser or a draw? And algorithms are interesting, but again, not necessarily the focus of this book. So I'm gonna not fret about this too much, and just come up with a solution that I think works well enough. So what I'm gonna do here is I'm gonna say if as one, I'm kind of just sketching out on code again here. If has one board cell type dot o. So obviously I have a few more methods I'm going to have to create here, but like if X has 1, return true. If O has 1, return true. If it's a draw, return true. Otherwise, keep going. So now I got to make these methods private bool. Let's start with draw is draw. And we know this if every single cell is full. So we can say, let's just search through the whole thing. We'll go, for int row equals 0, rows less than 3, row plus plus, for int column equals 0, column less than 3, column plus plus. If board.get cell at row column equals cell type dot empty, return false. So anyway, let me take a step back. I wrote that in there very quickly. So we iterate every row, go down every row one at a time, go across every column within the row one at a time, and then check the cell at that thing. If it's empty, it means we can play on. We haven't filled up the board. It's not a draw yet. So we return false. It's not a draw. If we get to the very, very end of all of this and fail to find an empty spot, then the board is full. And in theory, we've already checked, we're winning. It's full. No one's won. It's a draw. So we return true. I will say that I just typed it all up pretty quickly. I've done that kind of thing a ton. So it's at this point, it's kind of just secondhand nature to me. But I will say that the first 30 times I did something like that, it took me a while to mentally work through it. So if it took you an hour or two to figure that out, don't worry about it. That is part of the journey. It gets easier. You'll be able to solve bigger, scarier problems faster and faster the more you program. All right, so now we got to do this. Have we won? So I'm going to do similar thing. Private bool has won. And we'll do board, cell type. So this is interesting. We can win, a cell. If we get 3 X's in a row, up and down, or the 2 diagonals, then we've won. There is a way that we could do this with loops. We could say for int row equals 0, row less than 3, row plus plus, and go down the rows, go down the columns. We could do it that way. We'll talk more about that in a second, but we could do it that way, but I'm going to do the simplest thing that could possibly work and say, I'm just going to, there's only 8 possible things, only 8 ways to win. I'm just going to kind of brute force check them all. What I do kind of want is I'd like a RC board. If our same true. So if A equals B equals C equals D, return true. Otherwise, return false. Actually, we could probably simplify this a bit. Because we could probably say just return that, and then we could actually use an expression body. Again, not everybody likes that. That's fine. If the other version's more readable, stick with it. But so basically, if I got 4 things that are all the same, then we are good. I actually kind of want to put this one first, though. Yeah, so if each of these are all the expected type, then we're good. And so we just now, at this point, we just need to do this for each row, for each column, and the 2 diagonals. So that's each of the rows. That's each of the columns. And then I need to get the 2 diagonals. So it makes that brute force. We're just, there's 8 possibilities. We're just gonna check them all and be done. All right. Now at this point, so all this code here, so is game over, and that builds on, has one, which builds on this are same, which and this is game over also builds on this is draw. So like we have a lot of code here that's just related to win conditions, and there is a lot to be said about maybe that is a compelling reason to separate it out, even though it isn't like the that single responsibility principle that we talked about. The is there more than one reason to change, and if so, are we actually going to use it? Sometimes just because one of the things about this is if any single element it takes too long to understand, then that's problematic. If we can like cleanly separate the winning stuff out from this, then even if we don't expect it to ever change, that could be a reason to make another class for it. And it's 30 lines of code, and maybe it's justified. Maybe we should do it for that reason alone. But in this case, I'm going to not worry too much about that. All these are private methods, so anybody using the game doesn't have to think about that. So again, like we could change it down the line really easily if we need to, because like the only people who know about any of that code is the insides of this tic-tac-toe game. So I think let's make sure we okay, so the game did end, and maybe it would be nice to like when the game ends, like let's draw the thing and then like say something like if what do they call that method? If has I made an assumption here that's probably not great. Maybe we should do something like that. See if we can make O win this time. Okay, O1. Let's do it one more time with a draw. The game is a draw. All right, so it looks like each of the players and the draw are all taken care of now. So I think we're good here. I will say, like, remember how the renderer like knows like how to convert to like whether it's an X or an O. Like here, we're just taking the cell type. And so again, all the same things we said about like, what if we want to use a different name for that? It kind of falls apart. Like if it were not very resilient to that type of change here. Perhaps we could go back to the renderer and do something like renderer.draw dot display outcome. I don't know. I think we could display the outcome and maybe tell it what the outcome was, because this object, the game, has the logic for deciding who won, whether it was a draw or who won. So there's a little bit of like, I think there's more we could do here, even though I'm not going to do it right now. But like, the renderer knows how to display stuff. The game, or potentially whatever ends up having these win, like the rules to decide who won, knows what the outcome of the game actually was. And right now, it's like we don't have all that information in one place, and we need to get it all there. So if we made, for example, like a game outcome enumeration with the options of player 1, player 2, and draw, then we could pass in, like, depending on all these things, we could just pass in outcome.draw. And then this thing could update, like it could display that. I am taking a shortcut here, and that I should, like, maybe I shouldn't. And again, for if we're going to be maintaining this for the long term, I might do it otherwise. But that's what I'm doing for right now, and I'm just going to leave it that way. The last thing I want to touch on, though, is this has this answer this question: how might you modify your completing game if running multiple rounds was a requirement? For example, a best out of 5 series. Really, I would probably just come up here to this main method and just put in a loop. If I felt like that logic got very complicated, I do like what we did before when we made this Tic-Tac-Toe game class, and have like a Tic-Tac-Toe series that knows, like, oh, this happens to be a best out of 5 or a best out of 3 or whatever it is, and like check and see, like, how many times has player 1 won, how many times has player 2 won, and like if the one player gets enough of them, and then it just ends the series then, or whatever it is. I actually thought, I'm thinking of a different one. The 15 puzzle has the question of, would your design need a change if we wanted to make, different sizes of boards? Like, I thought that I was going to come up here, and then when I went to look at the question in the book, it wasn't that. But I do want to talk about that for a moment. This code has made so many assumptions that this is a 3x3 board, and I'll point out a few of them. I mean, this, for one, like the input, if we needed to support a 2x2 or a 4x4 board, like, this would need to all be very different. The renderer here assumes it's 3x3. It would need to change if it weren't 3x3. This right here assumes that it's 3x3. Like, we're never given a size. So, and there was something else. It's all the win. I collapsed it. Has one. Like, it's all this stuff. This is making an assumption here that it's 3x3. And this, like I said, it's hard-coded. It just says, I know these are all the possibilities. If we needed to support a different size, this is going to get a little tricky. I think if I had to do that, I would start by coming down here and making this like public board int size, or maybe like if I expect it to be rectangular, not just square, like if it could be 3x7. I can't imagine a tic-tac-toe game that would work like that. Like, anyway, 3x7, like, it would be, you'd pass in the rows and the columns, and then I would make a public int size, or public int rows and columns. and have that. And then most of the rest of the code should be able to build on that size to like update their logic. So that's what I would do. But like I said, a bunch of the stuff was just, it just assumed. And like I'd have to turn this into loops, and I'd have to turn this stuff into loops. And that code is harder to like think about what, it's harder to understand at a glance because it's just a bunch of loops. It's also harder to like write and make sure it's correct. Once you know you need that, if you know you need a 4x4 board, then that would be a lot better, I think, than like if the size is 3, then do this. If it's 4, then like this just bigger and uglier and scarier. If it's 5, then that again just bigger and uglier and scarier still. Like once you know you need that flexibility, taking the time to turn this into loops is worth the cost. But again, I for what we're doing here, assuming a 3x3 thing for tic-tac-toe is not totally unreasonable. It's just, again, in terms of software design, a lot of this comes down to what types of changes are actually likely to come up and designing around that. And it stings when something that you assume there's no way in 1,000 years will ever make a 4x4 tic-tac-toe board. And you have 1,000 lines of code, or heaven forbid, 1,000,000 lines of code that all assume a 3x3 board. And then somebody comes along and says, nope, we got to have a 4x4 board. And you have to like rework so much code to support these other sizes. So the more entrenched, the harder it is to make the change, the more painful it'll be. And the like, I guess the other side of that is if you try and account for every single possible way that something could change, you'll end up with code that's a lot more complicated. And for no benefit, because you're not actually benefiting from that. So that's, I think, one of the hardest parts of software design is correctly predicting what types of changes are going to be needed and designing such that those are easy. I think a part of the solution to that is like be generous with it, like assume that more is going to change than you expect without necessarily going over the top. Make concessions, little concessions, and I think an example of that would be that if we I don't know, even just making that property down in here that's the size could have helped a bunch of the stuff. We'd end up with a lot fewer 3s everywhere. This kind of stuff. So it's like I said, it's hard to find that balance because the more flexibility you attempt to account for, the more complicated your design will be. And if you never leverage that flexibility, the code's just more complicated for no real benefit, and it'll just slow you down. On the other hand, when you get to one of those things where you suddenly realize, oh, I need that flexibility. I need to be able to change it in that way, and you didn't account for it at all, really hurts too. And that's the nature of software development. Like I said, all these principles, like the single responsibility principle, are meant to help you think through those trade-offs. And you do get better with practice, experience. Like you learn, oh, hey, this is the kind of thing that might change. I've dealt with these types of problems enough. That is likely to come up. But in the long term, you will never get it 100% right. You sometimes just make a decision, weighing the trade-offs, knowing what you know at the time, and keep it simple. Maybe, like I said, it's excess, unnecessary complexity is not a good thing. But keep it simple. But yeah, like I said, it's hard because it hurts both ways. If you end up with extra complexity that you don't need, that hurts. And if you end up with no flexibility when you need it, that hurts too. So Your intuition will get better over time, but you're going to get it wrong sometimes. And so just like being able to change code over time, refactor, is a really important skill to have too. Now I'm just kind of rambling here, but I've been going at this for an hour and 45 minutes, so I'm going to stop here. But yeah, this tic-tac-toe thing, like I said, it doesn't have to be crazy. Most people, like, even when I ended up with 164 lines of code, I've seen plenty of examples of code that they maybe don't take into account all this stuff, and theirs is shorter. I see plenty that's longer than this too. I think, like I said, the main thing here is once you get to this level and beyond, there's a lot of ways that you can do it. And it doesn't mean that one way is better than the other. Like, for example, just because mine ended up this way or the solution I have online ended up a certain way does not mean that if you did it differently that yours is wrong. Yours might be better for your context, even though it's the same program. So anyway, software design is a tricky thing, and it, like I said, lots of principles, but sometimes and lots of like guidelines and rules and principles and best practices that are out there, like that single responsibility principle. But like writing lots of code and then thinking critically about, did this work? Like, is like, I've been like, it's 6 months on, was that complexity worth it? Did I need that? Was that helpful or not? Like, did this particular tool make sense here? And thinking critically about whether things worked or not is important as well. And the other part is sometimes you just get it wrong, and that's okay. we all do. So anyway, that is plenty for this. I apologize for such a long video. Hopefully it's helpful though. So anyway, that's all I've got. Thanks for joining me. I'll see you guys in the next video.